Cool, we should be live. We should be live. Fantastic. Let's see here. Got people messaging me. So let's make sure that the stream is up. Looks like it is. Fantastic. Cool. All right. So, where I left off is I was deciding basically how I wanted to handle a few things. And so, let's just say some things I'd like to figure out today. So, first thing is first, I would like to figure out project structure. Hey man, what's up? Welcome. Man, you're like the first person here. What's up? how are you, man? It's been a while. And so some things I have to figure out today is project structure. I have a better idea of how I want to accomplish that. And then I'd like to get a ship working. So how I intend to do that is I have sort of an idea. So the ship class itself is basically just for hooking up signals that allows all the subparts to talk to each other. That way I could still make each piece like not single responsibility principle, but yeah. Doing well. I went full mode into making the trading card game. Hell yeah, man. How's that coming? That's awesome. I am currently I'm thinking about rewriting my entire game because it's getting to a point now where it's been getting pretty crazy. So on the old game, this was the first game I wrote in Godot. It's still not done, but I didn't know what I was doing and I ported it from Game Maker. And so a lot of the stuff I was doing here, I tried doing in a Game Maker way. And I'm just sort of running into lots of issues trying to add new features and build upon it. So for the last few days, I've just been doing lots of research on how I should handle things in a more Godot way. And I've learned about resources and how those can be advantageous. So I've been working on that. So now I got all this kind of stuff laid out. And I think what I'm going to do is I'm going to do a data structure that's kind of similar to what Dolphin was showing. So if we go to YouTube, the good old YouTubes, let me get my headphones on so I can hear this stuff too. There we go. All right, cool. So let's take a look at what's the guy's name? Godot project structure, and then I think his video will pop up. Let's see. It's the guy who made Dolphin. This guy organizing. Yeah.
Hey folks, thanks for joining me for a quick.
So this guy is really cool. He's making a game, which is awesome, and he kind of ran through how he's going to structure his game. And if you look over here, his project structure, he has assets, common, config, entities, localization, stages, and utilities. And he keeps his root pretty sparse. Most of the stuff is in entities. And then how he goes about that is he starts going into like the entities here. So let's see. I'll have the picture of the crab. Yeah, so basically he can organize them as much as he wants inside the entities, and basically every entity, like this sand crab, he groups all the assets needed to make that sand crab happen in one spot. And I kind of like that approach, so I'm gonna do something similar. I figured out I love game design. I'm okay at programming, but that was holding me back. TCG, no programming, just creativity overflow. But I'm glad you keep going with your spaceship game. Baby steps. Dude, I've been making baby steps the entire time. And hopefully now I'm going to make a big step with this rewrite that I'm thinking of. So I want to get the ship working to see if it's going to make sense to me and see if it's going to be worth it. Because The old one is just, I have lots of growing pains with it. So I think I'm going to re-architect just the little stuff I have so far to be, to kind of use all that stuff. So I've already got like ship stuff here. So what I might do is I might just make that entities folder. Entities. And then I'm just going to make, let's see, a new folder in here. And we're just going to call it ships. And then, so I might just move all of that stuff from data that I have in my ship folder. I might just move that under here. Boom. And because everything is all done in the editor, Godot just updated all my file paths for me. Yeah. That was one of the last things I did before stopping my latest project. File organization. I concluded that as long as you instinctively know where stuff is, that is a good file structure. Talvish is asking, do you like Arch Linux? I love the fact that it exists, but I have never really messed with Arch Linux myself. Let's see, if you even start to search for stuff you are unsure where stuff is, it's probably time to refactor file structure. That's kind of what I was running into with the old one, is I kind of knew where stuff was, but I mean, it's pretty packed. Like I have a literal file, a folder here called other scenes, which is not great. I also have like other, another one that was like, I don't know. I got some stuff in auto loads. There's some stuff in classes. There's random stuff. There's a random audio manager folder that I made for no reason. Like there was no rhyme or reason to any of it. I see Windows 11 requires 32 gigs of RAM. It does? Weird. I just installed Windows 11 on a virtual machine today, and I only gave it 4 gigs of RAM. So, I mean, I hate Microsoft and Windows, but I don't know if it requires 32 gigs. But yeah. There's like 2 conversations going on in chat. This is great. I always have a random folder that somehow becomes my most important folder. That's true. I always get like a kitchen sink folder of all the random crap. So now that I have entities here, and I just have, see, I don't know if I like this or not. I kind of want to move this back to how I had it, just to the data. I'm going to move that back to data for now. I should keep that where it's at, and then as I make more things, data implementations, I don't know. I'm just not going to worry about the file structure for now, because I think I was already doing something, and now I'm just throwing a wrench in all that works. So yeah, maybe I'll just rename this data implementations to entities. How about that? Ships, ship data. I don't know. I might just make a folder called stuff and then just put it all in there. Is DDR4 RAM still good nowadays? I mean, I think so. I'm still using it. Shit. We go to system info. Let's see. It just shows my memory. It doesn't show what type. I guess I could pull up my terminal and do like a neo fetch. Let's see. Neo fetch. So let's see. What do I got? Resolution, memory. It doesn't show what kind of memory I have, but yeah, I have DDR4 on here. It's still rocking fine. My computer's quite a few years old. I've just kind of upgraded the GPU and the RAM, and that's all I've done to it so far. All right, so let's see here. So for my ship class, I'm in thinking, because since I'm still trying to wrap my head around resources, I think I understand how they work now. My ship class is just going to exist to kind of plug in all the pieces. And then so each piece will do its own thing. So for example, I have a resource that is called ship data or ship stats, ship data. And ship data defines all the things that basically my ship needs. And then So for example, like I don't even know if I should have this texture. I think I'm gonna move that out somewhere. And because what I envision happening is basically there are a few things that are dependent upon the sprite. And I don't want to generate those like at runtime whenever I instance a ship, because that would be pretty cost intensive. So I'll just make several different sprites that all have their area 2D with their collision shape and the light occlusion shape just built on there. So I can make a bunch of sprites, a bunch of ship sprites, and then just swap that out entirely. So maybe I might just swap this out for texture. We can say which scene should we use for our sprite, which also includes area 2D shapes and shapes, etc. Okay, and we're going to change this. So it's going to be a sprite scene, and this is going to be of type pack scene, so that I can easily switch that in the editor. And if I rearrange my project structure, Godot will keep track of that for me. So that'll be fancy. Let's see. Talbot says I have an i7 12700, 16 gigs of DDR4 RAM. Yeah, that should be fine. Like, what are you trying to accomplish, Talvish? Are you like running Windows 10 right now and you don't want to update to Windows 11 because it's Windows? Are you trying out different versions of Linux, or do you have a specific goal in mind as far as like what you're trying to accomplish with your system? Because I know for me, my system's working for my needs mostly. I'm a little late streaming today because I spent the last probably hour or so trying to play around. Because I was planning on doing a different type of stream today. Some of the feedback I've gotten is that for my dev streams, it'd be nice to have some music playing. So speaking of which, let's put some music on. Music, instrumentals, and let's see, we'll do that one, that one, that one, that one. We'll do these ones. Open with celluloid. All right. There we go. So we got some little tunes playing, right? I could probably crank it up a little louder if need be, but we'll see. Do a little bit louder. There you go. So I was gonna see if I can rig up my interface to my computer and have Reaper up with all my effects and everything like that, and see if I can make some backing tracks or like some background music for the stream on stream. But I couldn't get OBS to pick up the output in a way because it was being used by the interface. It was weird. So I haven't figured that out yet. I have Windows 11 for music production. Yeah. I was using Windows 10. I don't think I went to 11 yet. So when I switched to Linux over a year ago, I was using Windows 10, and it took me a while to figure out how to get all my music stuff to work on here. And I'm still tweaking it, but I also have my old MacBook, which I just have GarageBand, and I've just been doing a lot of stuff in that lately. So maybe if I could figure out how to capture everything from my a whole separate computer and put it on the screen, maybe that might be a fun stream to do. But yeah, so there we go. So we got this pack scene here. That'll be good there. So now what we can do is data implementations. We can make a few ships. We have ship data, and then we're going to have create new folder. We're going to have sprites for our ship. So maybe I don't know if I should call it visuals, because it's more than that. I'm just going to call it sprite stuff for now. So in here, I'm going to create a new scene. I guess I should have this all be like some sort of class, probably. So maybe Here, let's think about it. Let's pop open color paint here. We'll do a pirate software special. You guys ready for this? Boom. Okay, cool. So now let's think about it. So we have our ship, right? Ship. Yeah. Look at that. So ship is just basically going to hold all the parts. So then we have basically ship data. SD. There we go. So that goes into our ship. We're also going to have our sprite, which I'm going to call I'm going to put like a smiley face, because that's like kind of what the sprite icon for Godot is. So we have our sprite, but also part of that we have the area 2D. Area 2D, right? So we have that, and then also as part of that we have our like collision shape. So I'll just put call shape. This is awesome writing. Okay, so we got that, and then we're also going to have our light. I'm just gonna put LO. I'm not even gonna erase it. LO for light occluder. And then for that, we're gonna have our occlusion shape. Okay. So all those are gonna be based off of the sprite. And these collision shape and the light occlusion shape, all that is gonna be based on this. So, and all that's gonna go here. So we're going to have to connect the signals for area 2D. So we're also going to have a controller, because we can have an AI controller or a player controller. So we're going to basically ship is going to connect everything. So the signals are going to have to be we're going to have to connect the area 2D signals. So I should have some sort of class or resource or something like that that determines, you know, how this looks. I might just make it a class, but I don't know if I want to make that involved. So yeah, we will connect those signals. We don't need to connect any light occluder signals. So we just really need to connect the area 2D signals. So we can connect that and basically connect it to a function of our controller, which could be cool. And so that's kind of roughly how I'm going to structure it. So we'll see if that can actually make that happen. So let's just, for now, let's just make something and get it working. So I'm going to do a scene. I'm going to do a 2D scene. I'm going to make the root a sprite. Sprite 2D. And we're going to do just like example right. Okay, so we'll hit OK on this. So, in this scene, we have example sprite. So we need to pick, of course, what our sprite is. So this is where we can basically go to our assets, go to our sprites, hand drawn. We have a bunch of ships down here. So just for fun, let's get our shuttle working. Syntocracy shuttle. We'll put that there. And we're also going to have a child node, which is going to have an area 2D. And then that area 2D is going to have a collision, probably a collision polygon, I would imagine. So that collision polygon, we're basically just going to draw the collision shape that our ship should have. Just like this. And we might want to make it a little more exact. So we can actually do this. It's also going to be a light occluder as well. So we'll do this. And that should give us like a pretty detailed... Oh, we should do this. There you go. Actually, I don't know if it needs that or not. Let's not do that. Let's do this instead. Let's get rid of that. There. So this will be a light occluder and collision shape. So this will work fine. So now we can add child node. We add light occluder 2D. Yeah. And then we're going to add, for this, we're going to add occluder, new occluder polygon. And then what we can do is we can just go here to our, and just basically go to this. I'm going to copy this, go into my occluder polygon, and I'm just going to paste it. There we go. So that should work. An occluder polygon is drawn. What the hell are you doing? To be set or drawn. It is. Alright, I'm going to save it. I'm going to close it. And then we'll see if I can reopen it if that warning will go away because I set it. There we go. It's gone. So you can see we have our collision shape and we have our light occluder shape. So cool. So basically what we can do is we can drag this into our example ship data that we have. So for example, for the Synthocracy shuttle, it's asking for a sprite scene. I can just basically drag that in there. That should give them the info they need. So in my, let's see, what is this? Ship test. We can get rid of this. And then what we'll do is we can just instance that. So let's see. Instance our bright stuff. I'll add like another to do. Figure out what to actually call this. Yeah. So and then what we'll do is we'll do ship data dot sprite theme. Actually no, we're gonna do this. Var spr sprite 2D equals sprite scene. We need to load it. So we're going to load it. And then we're going to instantiate it. That should work. Oh, actually, we don't have to load it because it's already a packed scene. So we can just do that. Perfect. Yeah, look at that. And we have, it tells us what it is when we mouse over it. That's nice. So cool. So that should right away give us something. So what should I do for my main scene? Like, do we have a main scene? We do. So for funsies, let's go to the main scene. I just want to drag my ship test on there. Let's see, I'll add it like right here, I guess. So if we run the game, we should have a ship. This is not showing. Oh, I never actually used it. Okay. Let's go back to our code. And then we will say, add child. And we'll just add our sprite. And then what we can do is we can connect all the signals and stuff from that as well. So there you go. You can see up there at the top left, we have our ship. It's instancing that little sprite. You can't really see much else to it yet, but hey, whatevs. So we are getting somewhere. So now I got to figure out how I want to handle like connecting the signals, because I need to have some sort of probably class or something for that. What I could also do, which I'm not sure how I would get the values easily, is so in this example sprite scene, how we have like this occluder polygon and we have this packed vector 2 array, I could store the values of that in ship data, but I'm not sure how I would easily get this without having to actually map it on the sprite. So I think just keeping this all as the sprite is fine. So let's go ahead and do, I think I'm also going to do another class. So let's make a new script. And let's call it, it's going to extend node 2D. And we're going to call it we're going to call it sprite scene. I call it sprite scene. What should I name this thing? This scene, this class is basically going to be responsible for the sprite, for the light occlusion, and then also the area 2D. The area 2D is going to have some sort of signal that gets passed up. So we will have to have that defined. So I'm trying to think of what we should name it. I mean, what I could do is I could just... just want to have it pre-built, basically. Ideally, I just have a ship ready to go. But I have to have the area 2D defined. And that's determined by the sprite. So I'm just going to call it sprite... Not sprite data, because it's not necessarily the data. Sprite stuff is what keeps coming to mind. I'm just going to call it sprite stuff. So... yeah, we're gonna make it called sprite stuff. Okay, so let's go into our script of sprite stuff. We're gonna make this a class name, sprite stuff. And basically what sprite stuff does, sprite stuff contains the sprite 2D with the texture set, and also an area 2D with the collision shape. Actually, an area 2D and light occluder 2D with the polygon shapes set. So what we'll have there is we'll have to get a reference to our area 2D, which we can't do unless it's on ready. But we will have signals. So maybe I don't want to do a signal to this thing. So for example, area 2D, I could connect its signal whenever we have like an area entered or area exited. I could do that and then connect it here and then just have a signal defined that just extends that up. I probably should, but that seems kind of messy. Whatever, we'll do it. So let's see. We're gonna just connect area entered. Oh, we don't have a, here, let's attach a script. Actually cancel, let's just drag this onto it. Boom. So now we have that script there. So let's just attach area entered connect, and area exited, connect. So we can connect that, and then what we can do is we can just define some signals. So signal, and we could say SPR area 2D. This will do how it says area 2D entered. And I don't think we have to provide anything. So let's take a look at signals. Like I want to see what we got. Godot 4 signals. Because I know signals went through some changes in Godot 4 as opposed to Godot 3. So I definitely want to take a look at that. So, custom signals. So they're just saying health depleted. They're not really specifying. Okay, so they do specify like what it takes. A signal can optionally declare one or more arguments. Specify the argument names between the parentheses. Can I specify what data types they are as well? Because that's a big thing I want to do, is I also want to specify the data type. So we can do area. And can I make it area 2D? Can I do that? Will it let me? Looks like it. So we're just going to basically make a signal to pass it up, because basically anything above us should have no insight as to what we contain, but it should know what signals we expose. So since our sprite is our top level node, our sprite should be aware of its children, and it can basically just pass these signals, just relay them one to one basically. So we will take that and we will just simply emit signal, and we will just emit signal, let's see, SPR area 2D entered. And then do we still have to bind the arguments like we did in the old one? Oh, actually, we can just do it this way. Emit, and we can pass in the values. That's awesome. So let's do it that way. Instead of doing it the old-fashioned way, let's just do SPR, area 2D entered, emit, and we can just pass in area. Look at that. Beautiful. Too easy. SPR, area 2D exited, dot emit, and we will just emit the area. Cool. So that's really all this should really need is this stuff here. So we'll just say define, let's see, since the sprite is the top level node in this scene, we have to relay the signals from our area 2D so that any node can subscribe to it. So I could just do like an onReady variable and then just have that as a property, and then they could access it, but that, I don't know if that's the way to do it or not. So for now, I'm just going to relay it, which might not be great. It could lead to a delay in things, because signals are sort of asynchronous and they're not really processed in any order, and there is a delay in that. So I'm not sure if this is the best way of doing it, or I could just get a reference to it. Actually, let's just comment all this stuff for now. We'll do a onReady var area, and we'll just make it an area 2D and equals, and we'll just do area 2D. And so after we've added it to our scene and it gets instanced, then our main ship node can just basically connect the area signals directly. So here we expose our area 2D so that anyone can connect to its signals as needed. And I can put without having to relay them. Right? And I think if we do it in like double, It should show up whenever we mouse over it now. It should tell us like what it is, so externally. So that should be fine. And then we'll just get rid of this for now. Let's see. I'll just put here to do. Decided against this approach. Remove when sure I will no longer need it. Okay. So there we go. And I could put up here in the description, this node has a property named area that references the area 2D so that you can connect its signals as needed. Okay, we got that going. Do have repeat going, perfect, so that's fine. All right, yeah, fun stuff. We are breaking stuff, see if we can make it work. So now that we did this, we added it to our scene. So now we can connect these signals that we need to. So I might do that later. So basically we're going to instance all of the stuff that we need. So we're going to have our ship controller as well. I guess that's specified ahead of time, potentially. So ship test, we don't have anything added. So controller is going to be how we are controlling the ship. So what we can do here is we can say, let's see. First, let's instance what we need. So then we're going to do sprite stuff. And then we're going to do controller. So we'll do var control. I'll just call it controller. And then we'll do this as a ship controller. Actually, you know what? No. We already have controller declared. So we can just say controller equals, and what we can do is we can do player controller dot new, since it is a, well, actually, I guess we should determine whether or not we are controlled by the player, huh? So I guess that'll be determined by this. So whenever I want to create this, I can specify what type of controller it should have. So we have to like make it work. Maybe we can do like a controller dot instantiate or something. I guess we don't need to, because we have it defined. Once we add it, this is basically a resource. So I don't really have to load it. I mean, I could. It's part of the scene. So for example, like ship data is a resource. I'm not loading that, I'm setting it. So if we go to our 2D node, we hit this over here. You can see we have ship data, synthocracy shuttle ship data dot resource, and then we have a player controller. So we'll have to basically assign what the controller is when I'm creating the ships. So that will let me define basically what type of controller it should be. So that's interesting. I like that. That's cool. So yeah, let's just say that for now, I think all I have is just player controller. And I think I already did the code for that. Yeah, so player controller is just getting the inputs, and then it is just returning ship controls. Okay. So we have that. We don't need to worry about the controller. So with that, so that's all we're gonna do in ready. We'll do to do connect signals because that still needs to be done. And then, so in our process function, process called every. We'll just do this. Process is called every frame. Delta is time elapsed since last frame. I think that's basically like what it says. So we have that going for us. So I'm just going to put a pass and then a to-do on here right now. That way it stops giving us errors. And then we'll figure out what we have to do. So based on our controller and our data, then we're going to move our ship. So let's see how we're going to do that. If we refer to the old project, we'll probably use a lot of the same logic. So if we go to process here, so we're basically determining if we should be destroyed. I don't like how I did that, so maybe I won't do it the same way. So I won't worry about that for now. We don't have to worry about if we're the player or not because we're handling that by the controller. And okay, cool. So we're basically declaring a fresh vector to add motion. So let's do this. Declare fresh vector for our velocity slash motion. And this is, I'm gonna call it velocity, but I'm just gonna, let's just stick with motion for now. So motion is of type vector2 equals, and we'll just do vector2.0. Is that a thing? Here we go. I mean, I think if I would have just left it, it would have been declared as that, but it's nice being explicit. That way you can see what's going on. So ship rotation. Note that Godot rotates opposite of GMS2. That was a note I made to myself because, yeah. So decrement equals rotate to the left counterclockwise. So yeah. So if, then we have actions, rotate left. So we're doing this stuff here. So rotation, we are rotating our whole scene. So then, let's see. Determine what to do based on ship controls and input, right? So ship controls. So I guess we could do like get the input from our controller. So we'll say var input equals ship controls equals, and then we'll do controller dot, and then I think we had a, oh, this is where we have to connect that signal. Ship controllers changed. So how am I gonna connect this then? So let's go back to our ship controller. So we have a signal. So let's keep reading. How did I handle like floating through space? Did I have a variable called like motion? Oh, I had a variable called velocity that I was basically using for that. And I had setters and getters as well. So set velocity emitted a signal saying our speed changed. Okay. Interesting. So ship I guess we will have to have some stuff track our movement as we drift through space. So for now, we're going to have a var called velocity, which is a vector 2, and it's just going to equal vector 2.0 for now. Dot 0. There we go. So we'll keep that. So we need to connect that input, and then basically, so we're gonna not worry about this shit for now. So let's cut this out. We're gonna put a to do, translate our velocity, because that's what we'll be doing every frame regardless. And then we'll probably have to do like a function to connect. So we'll do a signal connector function for our controls, for our controller. So we'll do func. We're going to do a internal function. Let's see. We'll just do input changed. And then we're going to add input as a parameter of type ship controls. And then for signal connector functions, I don't return void, because for some reason that messes up the callable pattern that Godot 4 has. So I'm just going to have it not return anything, but not explicitly say it's not returning anything, if that makes sense. So then what we're going to do here is just move us down here. We're going to declare a fresh vector for our velocity motion. And we're going to get the input from our controller. So we already have that defined. And then so now we're basically going to handle rotation first. Handle ship rotation. And then we're going to handle probably... what do we do next after that? So in process, we handle rotation. We do ship thrusters. That'll be something that we're going to have to connect as well, which is fine. So rotate left, rotate right, accelerate, decelerate, strafe. So movement stuff and boost. So all that stuff will be here. Okay. So that's fine. So let's see here. So I wonder if we should be... So I think we're going to be adding to our velocity every time. It's basically what we're going to do. Yeah, so it's setting velocity plus equals motion basically every time we are doing something. So I can do that same pattern here. We're making sure our speed is capped, and then we are translating ourselves. Okay, so I can kind of do something similar. So let's just handle rotation first. So let's see, if input dot let's see, rotate, is that what's called? Turn left. So these are all booleans. So this is going to evaluate to true or false. It already does, so that's fine. So if input turn left, let's give some more space down here so I can freaking breathe. If input turn left, then what we're going to do here is, let's see what we're doing there. We're just rotating our ship. So rotation, I could do a rotate, but I think that doesn't work how you expect. Equals, so we're going to do a vector 2, and how we did it is we do 1 and 0, and that basically makes a vector going to the right, which is the base like direction, and then we can rotate it as needed. So we're probably going to do a plus equals, and then we're going to do rotated based on the angle. So we're going to do degree to radians, because Godot uses radians, but I'm more used to dealing with degrees. And if we look at our ship data type, we have turn speed, which is rate of rotation turning in degrees per second. So we can just go here and say rotation plus equals ship data dot rotation. I guess turn speed. Turn speed. Dun dun da 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 da. Is that how we're doing it? This seems silly. Oh, we're just directly modifying it. I'm thinking too hard. So let's keep the degree to radians. And I think we have to multiply that by delta, if I remember right. Yeah, so we multiply the final result by delta. So if we're turning left, which is counterclockwise, so we're gonna remove that basically. Oh, we also need to have that. How are we gonna do that then? Because input changed is not gonna have access to that. So I think the easiest way to go about it is we're going to export our controls, which is ship controls. So we already have access to that variable, which is not clean. I could have a function that is like get controls, but that would just return controls. So all right, let's just move all this back in the process, because we're going to want to do this like every time anyway. So we'll say, let's see, handle rotation. I'm going to get rid of this ship for now. Handle ship rotation. What we're going to do is we're going to say if controller dot controls dot turn left, which is a boolean. We're just going to say rotation be minus equals degree to radian. We're going to do that ship data dot turn speed, and we're going to say multiplied by delta outside of it. Delta. And then we're gonna do basically turning left and turning right. If controller dot controls dot turn right, and does this say what it is? No description available, whatever. So rotation plus equals, and then we can just copy this. There we go. So we should be able to like move our ship now on base object type nil. Why is it nil? So this ship does have a player controller defined. But why is it saying nil? Turn left. On base object nil. Okay. Let's take a look at our ship controller. Ship controls.new, right? Can we do that? Does that work? Nothing is happening. Okay. So we're not detecting any of that. So where's player controller? Oh, we have a function called get ship controls. Okay. So we don't actually need that then. So we don't actually have to do output. We can just say it's actually controls, because we're declaring a variable that we don't need, because we're extending player controller, or we're extending ship controller, and ship controller has a variable called controls. So we don't really need to export that either. So we can just basically make that internal. And then we're going to go back to player controller and just change output to controls. And I'm going to replace that one, 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 that one. So yeah, that would work. So we're gonna just get rid of this. In theory, this should work. I did not click you. Why are you doing that? Stop it. Okay, so we have to call that get ship controls. So what we can do here is get ship controls. So far, get, let's see, we'll say input, which is ship controls, equals, and we'll do our controller dot get I guess we could do, so what do I have it here? It's called get ship controls. So I wonder, can you override? Because I want to have that declared at the top level. And then should be overridden by, I guess we'll just put return controls. So that's really all it should do. So we'll save that, and then what we can do here is we can just overwrite it with our own. And that way we're getting that. So I wonder if this should overwrite it, yeah? But in our ship, we should still be able to call get ship controls. And that should return that. So then we can go to if input. See, this is feeling messy already. I feel like I'm just missing something silly. But I think once I get it, it'll make sense. Oh, I see. We don't need that. And we don't need this. There we go. Our ship is turning. Look at that. Cool. So step one done. So we're getting our input from our ship controls, which is awesome. And then, so we've handled ship rotation. Perfect. Let's also make this sure it's spaced out so it's more readable. And then now we should do, what do we do next? So then we did actual movement. So we do acceleration, deceleration, strafing. Okay. Moving the ship. So we'll do var motion. It's a vector 2. And we're going to just initialize it to vector 2.0 to be explicit about it. Let's see. We'll add this to our velocity. So then we're going to do, let's see. Let's actually add this comment over here. Let's calculate our motion. This will be added to our velocity so that we get that cool space feeling of drifting through space. So we'll get that cool feeling of drifting through space. That's more succinct. Period. Bam. Look at that. And then we're going to do acceleration. So we're going to say if input dot accelerate. Then we're going to do motion plus equals, and we're going to do a vector 2 that is initialized to basically an arrow pointing to the right, because a vector is an arrow representing both direction and magnitude. Vector, oh yeah, oh yeah. So we're just gonna basically declare it as like a value of 1, and then we could scale it and rotate it. So I think we rotate it first and then scale it. So rotated by our rotation, and then multiplied by our acceleration speed. So yeah, fun stuff. So then we'll do rotated by our rotation, and then we're going to scale it by our ship data dot acceleration. If we mouse over that, rate of acceleration. Okay, cool. So we're not applying our delta to that yet, because I think since this is all going to be added at the end, we apply the delta before we actually call our translate. So we'll do acceleration and deceleration, because they're both very similar. If input dot decelerate, and we basically do like the opposite, where it's not quite the opposite, no. I see. So we're just decreasing the magnitude of our velocity. Okay. So that's what we're doing here. So we're not going to do this here. We're going to do velocity. What did I do? Plus equals. New speed. I see. Bar new speed, which is a float, equals, and we're going to do velocity.length minus, and we're going to do ship data dot deceleration, and then we're going to make sure that new speed, if new speed is below 0, we're going to cap it at 0. New speed equals 0. And then we're going to scale our velocity. So velocity equals vector 2. Well, that's not right. We're scaling our velocity. Vector 2 1, and 0. Is that how we did it? Velocity normalized multiplied by new speed. That was it. We normalized it. Equals velocity dot normalized scaled by our new speed. That's interesting. We are applying that there. And we're not doing our delta either. Why are we not doing that? Oh, because we apply our delta at the very end before we translate. That's why. We got that. If input decelerate. Okay, cool. And then what do we have left? Strafing. Okay. So then what do we do for strafing? Actually, I'm going to put a big old to-do on this for right now. And then we're going to what do we do? We did translation. Basically detecting our max speed. So we're just handling our max speed. Ensure we don't exceed our cap speed, our max speed. So we're going to say if velocity dot length. Actually, let's see. We need to add our motion and stuff to it first, right? Oh, I see. So we're going to apply our motion first. That's what I thought. Apply our motion to our velocity. So we're going to do velocity plus equals motion. And then we're going to say if velocity dot length is greater than ship data dot max speed, then we're going to say velocity equals velocity normalized, because it's going to make it like basically just the length of 1 whatever direction it's going. And then we're going to scale it by ship data.max speed. There. So that's quick and dirty. We're going to have to do something else once we figure out boost, but for the most part, that's basically it. And then now we need to apply our translation. So now, I think that was just a simple one-liner, if I remember right. Yeah, we're doing all that fancy stuff. Translate velocity multiplied by delta. So we're going to do translate velocity multiplied by our delta. So this should allow us, look at that. Perfect. We have it working just like it did in our other game. So player input is working. We can slow down slightly too if we decelerate. Awesome. So cool. So we have that working. Now another thing is our thrusters, right? The old game had thrusters. And the thrusters had I had a lot of logic that sort of determined like what the thrusters did. In reality, I didn't really need to do all that. I had like a separate ship thrusters component, and I probably should have something like that here. So let's think about how to do that. So we have a ship moving, it's working. It's working how I intended it to. It's got the same logic it had in the old one, minus being able to boost and stuff. But for now, it is working how I expect, which is cool. In the old game, it followed your mouse cursor. So that's interesting. Another thing I want to test real quick is, let's see. Oh my god, do I even have the USB ports available? There's too many USBs going on. Let me get a longer cable. I want to try to test a controller and see if my controller inputs work as well. So give me a second. I'm gonna go dig up a long USB-C cable. You're gonna find it. Where are you? Not a very long USB cable. So I have a plan. I think this is a light. I don't need to have that plugged into my computer. So give me a second while I check. Here are the USB ports. Sorry for bumping the microphone. Well, damn it. Can't make this reach all the way. Okay, so that's kind of weird. I can't do it. Maybe my headphones can move. Okay. Now I should be able to connect this cable over here. Cool. So let's get this back up here. There we go. Okay, so I got that, and I have a cable just long enough to be able to do this. Holy shit, I can move. Oh yeah, this is awesome. I'm off the fucking screen. Okay. I've never played with a controller with this before. I've played with controller obviously, but I've never made a game. Okay, this is weird. This does not work how you expect with a controller at all. Okay, I'm gonna have to rethink controllers for sure. Because this does not work how you would intuitively expect it to work. Interesting. Okay. But we know it works, which is massive. So I'm gonna have to think of how to do the controller input to make it work how you would expect. Because that is awful on controller right now. But just for fun, let's go to project settings, input map. So to accelerate, it's tough because it's not what you would expect. So I'm not sure how to reconcile that at this point. So I'm gonna leave that alone for now. But it's working. So we can play it. We can do with our ship. This is awesome. This is cool. This is fantastic. Awesome. Sweet. So what we can do, we could probably make it work like we did with, maybe similar to how it did with like pointing towards our mouse, basically. So we just rotated our ship to our global mouse position. And this is a big old thing. I remember this. Got a lot of code in here, man. Holy crap. Okay, so we have that working. On a basic level, we have that working. Let's do strafing now. Strafing, if I remember right, was pretty easy. Just basically shifting our... rotating, yeah, or basically just adding or rotating 90. That's right. So that's easy to do. So let's do if input dot strafe left, then we are going to motion plus equals. Then we're going to do a vector to 1.0 rotated by our rotation plus, and we're going to do our degree to radians, and we're going to say minus 90. So I guess we could keep this to 90, and we'll just subtract it, because that's what we really want to do. Subtract what our current rotation is, subtract 90 from it, and that's basically what we're doing. And then we can do multiplied by ship data dot strafe speed. I think that's what it had. Let's go take a look at ship data. Max speed. We didn't define strafe speed. Interesting. Okay. So we'll just do it here. The rate at which we can strafe in pixels per second. I think. Sort of like, it's basically, yeah, I don't know. That's not quite right. At which we can strafe. And then we'll just do an export bar strafe speed of type float. We'll save that. And then what we'll do is in our implementations here, we have Synthocracy shuttle ship data, strafe speed. I think we could just set to 1 for this. So we'll save that. And then we can go into our ship data dot strafe speed. So we're scaling that, and then again it will be scaled later. So that should work. If input dot strafe right, we'll do the same thing, except we'll just do a plus copy. There we go. So now I should be able to go here. If I slow down, I can strafe. Look at that. I can strafe, which is handy for flying around trying to like destroy enemies. You could potentially evade bullets and stuff that way too, which is cool. So it just adds a little bit more control to the ship, stuff that we've done before. Okay, so we have a ship working. Let's figure out the thrusters. Okay, we don't need this. Ooh. Oh my god. Dude, what the hell? I got so many messages now. Wow, okay. Nice. Okay, sorry, I just had a few people message me. I'm trying to respond to them. Jesus Christ. Cool. I got a bunch of emails. Holy shit. Okay, with how many notifications I just got in the last, like, 15 minutes, you'd think that I was being called back into work and everything's on fire. But no, it's just people sending me memes. Okay. Amazing. Alright, let's see. So, let's review what we've got. So, to see if this is any better than how we're doing it in the old way. So the old way obviously has just a crap ton of stuff in here. We're basically just recreating the basic stuff that we know works. Are we getting anything from it? There's a few advantages that I see to resources already. And the reason why I'd want to do it in Godot 4 is because of the typed arrays and dictionaries. Godot 3 does not have that feature. So this does give us the ability to do some cool stuff. But do I need to actually rewrite it entirely? Or can I just refactor it to make it cleaner in place? So for example, save data could probably just be a resource. Maybe. I don't know. Oh my god. What? Okay. I think I'm at a point now where I want to do some thinking on this. I want to sleep on it. Because I'm still, like, the wheels are turning up here. And yeah. So it's making sense. There's a few things that are kind of wonky that I'm not sure if I really like the way that I'm handling it. So for example, ship control or ship controller returns the ship controls with the current input values. Okay. And then what we're going to do here is to do should be overridden by specific. We'll do by player / AI controller subtypes, if that makes sense. So there you go. So our player controller overwrites this method, and it does it based on player inputs. And then our AI controller can implement the same method, and it will do that based on a whole lot of potential stuff that we need to get, such as like ship position and things like that. So yeah, interesting. Still got some thinking on how I want to handle that as well. But we made progress. We have a ship that can now move. And it moves the exact same way it did in the old game. So it's a 1-to-1. Minus the boost stuff. And like rotating towards the cursor. So we have that stuff there. This is fine. So we have that. That's awesome. Okay. I like it. So let's clean some stuff up though. So ship controller, see if we can make that a comment. Make that like exported comment basically. We don't really need that, but we can do it. We could do it anyway. So maybe we just, since we have get ship controls, we might just make that like an internal one, but that's fine for now. So we have that. I don't know if we need this signal or not, but this doesn't hurt in having it. We're not emitting it at all right now. But what we should do is for our player controller, we can do like a check at the end to just compare like, hey, does our well, I don't want to do that because that's like a computational thing. So yeah. Oh shit. Oh. I mean, we could just do like a var. I don't know. I don't want to complicate this. This works for now. I'm just gonna add a to-do for to do we actually need this? With our current implementation, no. But we should reevaluate whether or not we need this because it's not even used yet. So we got lots of stuff defined. So another thing I have to think of is for our ship stuff, or sprite stuff. I gotta do some thinking on how to handle this as well. And on top of that, we're probably gonna have to have our thrusters on there. And those are gonna have to be defined by the sprite. Definitely some stuff to think about. So yeah, anyway, I'm going to stop this stream. I'm going to grab a quick bite to eat. And I'm going to come back and probably play some Terraria. Because I don't want to continue working on this right now. I want to sleep on it and do some more thinking and research on how I want to handle things. But for yeah. Yeah, I'm going to sleep on it. Anyway. Thank you all so much for watching this. In a few minutes, I will jump on some more Terraria for a few more hours before I go to bed. And yeah. Oh my gosh. Small baby steps, incremental progress. Anyway, thank you so much for hanging out. Appreciate it. And I'll see you guys next time.